So today we're going to go ahead and talk about series circuits. In series circuits, there's only going to be one pathway for the electrons to flow. So let's go ahead and draw a series circuit. So to represent a battery, again, we'll use a long line and a short line. And again, the longer line represents the positive terminal. The shorter line represents the negative terminal. Wires are just lines. And let's go ahead and draw our two resistors. Resistors we can draw with kind of a little squiggly type line. So there's a 47 ohm resistor and an 82 ohm resistor. We can think of those resistors as kind of like light bulbs or something like that. Cool. And again, if we're talking about the conventional current, even though we know in real life it's electrons that flow, conventional current, just by definition, is the flow of positive charges. So those would go from the positive terminal. Oops, I should draw it all the way around. So from the positive terminal all the way around to the negative terminal. So that's the current flow. Cool. So again, in a series circuit, there's only going to be one pathway for the electrons to flow. So let's go ahead and go through this problem. So we drew the circuit for B. Let's go ahead and find equivalent resistance. Equivalent resistance is a fancy word for total resistance. So I'm going to call it R equivalent is going to be just the same thing as R total. Just a fancy word for that. And in a series circuit, the rules are you're just going to add up the total resistance of each resistor and keep on going. So in this case, we only have two resistors. So we have what? 47 plus 82. And I get 129 ohms when I do that. Cool. So now let's go ahead and do C for what is the current in the circuit. So we know Ohm's law is V equals IR. And keep in mind when we do this, this is kind of like V total equals I total equals R total. Cool. And we're always going to start, when we start these problems, we're always going to look at the circuit as a whole. So we know as a whole the total resistance is 129. We don't know I. We want to find that. The voltage total is, oh, we know that, 45 volts. I should have labeled that on my circuit. So that is 45 volts. I can go ahead and put that in, and I get for my current 0.35 amps rounded. Cool. So looking at this, so the current through each resistor, since there's only one pathway for it to flow, the current through the 82 ohm resistor, I'm going to write that down. So the current through the 82 ohm resistor is 0.35 amps, and the current through the 47 ohm resistor is also 0.35 amps. Cool, so keep that in mind. In a series circuit, current stays the same. I think I have just enough space. Great. Okay. So now let's go ahead and do D. So what is the voltage drop across each resistor? Okay. So I already labeled some stuff on my picture. I'll go ahead and keep labeling. I should have labeled that that's the R and that is the R. Okay. So we want to find the voltage across each one. So let's say this voltage I want to find right here, and the voltage for this one I want to find. Okay. So we know Ohm's law is V equals IR. We can just apply Ohm's law to each circuit itself, or each resistor, excuse me. So V equals IR for this, so I have I is what? 0.35 times R is 82. And when I go ahead and put that in, I get 28.7 volts. Great. Now let's go ahead and do it for the other one. So V equals, I know IR. The I is 0.35 times resistance is 47, and I get 16.45 volts. Cool. So I want to found the voltage for each one. So now let's think about it. What is so significant about this number and this number when compared to the total voltage? I want you to think about that for a second, pause this video, and then check back in. Okay, cool. So let's look at it. So I bet you figured this out. But if I look at 16.45 and 28.7, if I just add those two together, oopsies, wow, that was a long one, plus what, 28.7? I'm going to get 45.15 volts, which is basically our total voltage. It's going to be slightly different because I had some rounding errors in my problem, but wow, that's cool. So the voltage drop across each resistor sums to the total voltage in a series circuit.